So
was.
yeah, that was beautiful, Aurora.
It was. I was a little mad that I couldn't go anywhere. I was in Kenosha. I was like, whatever, it's fine.
Oh, hey,
All right.
I couldn't go anywhere
Active.
either. I was watching that red aurora from where was I? Yeah, my basically my front yard. I was
Ah.
in the driveway. Yeah, it still was beautiful.
Yeah, it was nice. Well, according to my
Yeah.
computer, I am live. So let's
Yes,
see.
you are.
Let me look to
We
see if we
are live.
have it on my phone. Oh, there we go. Yeah. I titled it The Tale of CMEs and Coronal Holes.
Hmm. Yeah. Well, I have it under it's windy out there because it
Yeah,
is.
it is. So we'll see. Come on. Oh, the struggle is real.
Yeah.
It's like we got 6 minutes late because I can't get internet to work properly, so that's fun. And then I'm trying to get in the phone. Well, I mean, we have to like it's let it run for a couple minutes anyway, while it alerts people that we're live,
Sure.
so it's fine. But I'm trying to
Yep.
like click on it on the phone so I could see if anybody's in the chat, but it won't let me. It's being annoying.
I
I'm
have the chat going.
okay.
We're good.
We're good. All right.
All
We'll
right.
still let it sit for a minute though.
Sure.
Since the last time, I don't know, usually it takes like 15 minutes or something for it to really load, but we won't wait that long.
No.
We'll just roll right in. Yeah, there it is. It's windy out here. Looks like we got a couple people watching. Probably me. That's right. It's morning in Tasmania, so good morning on the
Yeah,
other.
well, one of them is probably me.
Yeah. Well, I guess if you
It's
want,
two of us and somebody else.
here,
Oh, yay. Hi, Margaret.
like, hi,
Hi,
hi.
Kev. Ah,
So I'm going to.
Chanel. Yay. Welcome.
Do you want to unshare it for
Yes,
the
I
screen of it?
can.
So I can,
Yes. There we
yeah.
go.
We'll do the official intro now that we have some people watching. And Janelle's here too, so that's
Yep.
cool. So welcome in. Sorry, apologize that none of this is at a regular time at all on a regular day. I'm all over the place. The Tanya can attest to this. Uh, what was it? Saturday, working 12 hours in the sun, so that was fun, and then rolled right into another tour on Sunday. That we had we had to drive 2.5 hours and then activate from 10 p.m. to 2 a.m.
Oh,
and
my.
then turn around and go back at 9:30 a.m.
Mm.
So we get done with that event at 5 p.m. and we drove 2.5 hours here. So I'm a little tired.
Yeah, I would say no horror chasing for you.
No, so it's been a rough couple days, but we're here. So that's why Tanya is gonna take the lead on most of this because I've been MIA for the past 3 days working, but we will, do our best, tag team. I won't let her do all the work. She did most of it. So if
Well,
you want to bring that wonderful slide deck up, we'll
all
go.
right. Let's do it. So, um, happy anniversary of August 11th storm.
Yes.
One of the most beautiful auroras I have seen from my driveway, actually. That was really exciting, but and we got nothing like that, unfortunately. I'd love to say that the forecast is for another amazing aurora, but
But
it's
it's
not.
not.
It's not, and that's okay. This is what happens. But we did have a couple of interesting events, and one of them actually happened overnight. So,
Yeah.
yay.
Without further
This,
ado.
yeah, this is what happened overnight. There was very short but very real interval of negative BZ with a very sharp transition into positives. And when that happens, you know what to expect. we're gonna get substormy weather, and that's exactly what happened. And again, this looked like sort of tiny piece of flux rope or tiny flux rope because you see both BY and BX. So that blue line and the red line, BZ is a red line, they kind of transitioned and there was a little bit of movement. So it looks like a flux rope for all intents and purposes, just very short. But that flux rope ended up being incredibly geoeffective, meaning it started as substorm, and that's that substorm tracker that Andy built from our favorite app,
Yeah.
Glendale. And that transition into positive BZ, so very sharp transition, actually resulted in super nice substorm. That was the red alert in Glendale. So that was pretty impressive substorm. Was it caught? Yes. Did we catch it? No. So I am over here, and I know that's not where you were, Mary
Yeah.
Beth, but that's your home base. This is
And
Chicago. So it
look how
lights up.
bright it is.
It's a very bright area, and you can see Minneapolis. This is Duluth, so that's northern Minnesota. Lots of clouds. This is Canada. Some smoke. You could see that too. So it's
Oh
smoke
yeah,
is
yeah.
definitely moving in. But this is Aurora. So this is the band, and this is Omega band because it's really trying to form that letter Omega. But that's where it was. So you can see how geoeffective that little thing was. It just didn't last very long, but produced nice substorm that was seen in, I think, Australia. Tasmania reported it. I saw it in the morning. I was very excited for people to see it. And Alaska caught it. So the aurora season is actually started
Yeah.
in a lot of higher latitude locations. So Iceland is reporting it, Alaska is reporting it, Norway is reporting it. So tours will be going. This is super exciting. And
Yes.
of course, this is a picture from one of the polar orbiters. It's Suomi NPP, and this is dynamic day-night band. So you could see aurora, you could see light pollution, you could see clouds, you can see Canadian smoke.
Yeah.
Yeah,
All of it, all of it. You see all of it.
all of the above. Yes. All right. So, kind of little story from that. Fast solar wind. We're expecting it to be fluctuating pretty wildly. So BZ is going to be all over the place, but it may actually contain some small structures with variable geoeffectiveness. If we are lucky, we're going to get a nice piece of flux rope with very consistent negative BZ, and with a sharp transition, it's going to generate a substorm. Um, why is it there and where is it coming from? So you could see those bright points inside coronal holes. Those are actually very, very tiny active regions. They do have very small filaments at the neutral line that lays between negative and positive parts of the active region. And that filament can be launched, and there are actually some research that's describing exactly that happening. And that could be that possible source of small flux rope and the fast solar wind. So it's not just BZ going all over the place. Sometimes it stays fairly consistent, and it can definitely generate some interesting stuff in solar wind and the magnetosphere. So we could get aurora out of it. And
Absolutely.
all right, so I think it's a good time to update where we at on solar cycle.
Uh-huh. Yeah, so we're well, as you know, we're in the declining phase, but we're seeing a bit of a surge. If you've been watching all the chats on Twitter and stuff like that, what was the sunspot number? Like 150, I think we're at.
Hmm.
So we're up from, you can see the dip where it actually fell out a little bit, and it was quiet for a while. I mean, we had those coronal holes that were pretty persistent, but now we're seeing a surge, and we have a lot more active regions again, which is nice. So this could make the next couple months pretty interesting, because it's been relatively quiet. We had a actually when Tanya was talking about the little structures in the fast solar wind. I mean, we'll get to this, but there were several little structures from CMEs that were glancing blows that were very hard to model. But but all you need is that little bit, and it just enhances that whole wind stream. So we'll probably see more of this as it goes on. So
Yep.
if you want to add
So
to that, but I
absolutely.
think
No,
that's summary.
that's absolutely right. There's definitely more to come. We
Yeah.
are likely to see active regions becoming a thing again and active regions flaring. You know where they like to flare, right? East
Yeah, on
Limb
the
and West
limb.
Limb? Sure. That's what they've been doing all day today. Anyway,
Well,
it's about time for them
or
to.
they flare center disk, but then there's a coronal hole that deflects them all to the away.
Yeah,
There's
we'll
that.
talk about that, but it's a complexity of this part of the solar cycle. So descending phase of the solar cycle is coronal holes are not going anywhere. They're sticking around, and they do nasty stuff with CMEs. So let's talk about the CME that happened recently. So this was the excitement of last week. August 5th, there was an M4.4 flare. It was definitely eruptive. We saw the dimming. And even in early dimming, it was fairly clear that something was in the way of CME. So instead of being sort of spread around fairly evenly around the point of eruption, around the point of flare, it got blown to the side. So why did that happen? Well, you could sort of see the shape of that coronal hole even in 131. So
Yeah.
normally you use this wavelength, this teal color for flares because they're visible there. But it's darker. So there is something there, and that's that coronal hole that was responsible for very nice deflection of near center. It's like, I don't know how close to the center you can be, and it still got deflected.
Yeah, it's
So
still got
that just makes everybody who wants Aurora cry when we see this deflection of CME from the center disk going sideways. But coronal holes contain a fairly strong magnetic field, and CMEs do not like to travel across um, magnetic field lines. They kind of choose, well, not choose, but they go with the path of least resistance. And in this case, it happens to be West Limb. Could you see a CME deflected in the opposite direction? Yes, you could. If something flares on the other side of coronal hole, it might actually travel faster because it's traveling through faster solar wind that was upstream of it, not upstream, but sort of downstream of it. And it may arrive at a different time and it may be deflected in a very different direction. But that's what happened. So modeling was very challenging. It all didn't end up going to the West Limb. Some of it actually came our way, and that was exactly what was modeled. So this is just a sample of how it was modeled and different agencies. So M2M, which is NASA, they actually ran an ensemble. So they ran, I think, 24 different NLILs with different speed. And it looks very interesting, but I think we need to cover it on a separate day. They got several times, estimated timing of arrival, and you could see the spread is anything from fairly early to fairly late. So SITSI is a Belgian, it's Belgian Space Weather Center. It's Solar Influences Data Analysis Center, and they predicted the arrival into the ninth. Um, this is what we got at L1. So could you tell where that CME arrived
I mean,
reliably
you
when the
can guess,
shock happened? You can
but
guess maybe, and we're gonna try to do that, but would I be very confident in my analysis that this is exactly when shock happened? No, there's just no way to tell the structure apart. There is a piece of something over here. We'll definitely cover that. There is a change in speed that is suggestive that something different is happening here. There
Mhm.
are some temperature differences, and but telling nice shock that we expect to see with a bump in speed and bump in density and just consistent numbers afterwards and sort of nice transition to a flux rope, good luck. That's not going to happen. And chances are we're going to see more of these events where you can't really tell heads and tails of structures because they're embedded into each other. And solar wind, again, doesn't have consistent magnetic field, so it can blend with other structures. It can compress them. If the CME is ahead of it, it might be compressed. So you can get very unpredictable timing of arrival. You can get magnetic field that's fluctuating all over the place, but overall, it's not going to be easy to analyze. So good luck
No.
to anybody who's trying, including us. And this is
Yeah.
this is just our shot at, okay, let's try to figure out what actually happened. Did the CME arrive? We think it did.
Yeah, we do.
So this was sort of a general picture of what happened. Again, one of the versions, in this case, our version, and this is a consensus statement from the entire Space Weather Unplugged. We ran it together. So this is what we get. And there's some agreement and some disagreement with other space agencies and forecasters. And again, you can get several forecasters together for this structure. You're going to get several opinions. So this is clearly a nice rise in the magnetic field strength. So chances are that's that co-rotating interacting region, which is a border of fast and slow solar wind. So slow solar wind is leading, fast solar wind is gaining up on it and compressing it, and that's the nice rise in the magnetic field. You get baby CME, which is really not a CME. It's more of that small flux rope that got launched and just got compressed, got trapped in the CIR. And then interesting things start to happen. So first of all, speed was kind of trying to rise, but it got a little erratic as far as where it was going. There's also change in temperature. So something else is happening here. Instead of nice rise in the temperature, it got a little jumpy. And most importantly, magnetic field got all raggedy. It's going up and down. So we typically see it in CME sheath when magnetic field is really not stable. It's fluctuating. BZ is going up and down. And this is kind of what's happening here. So is it possible that the shock of the CME got embedded in this fast solar wind? Yes, it's very likely that's what happened. There's also another sort of baby CME, another flux rope over here, because again, that looks very discontinuous. It's like
Yes, yeah.
magnetic field suddenly points in different direction. And that's very unusual for just pure coronal hole influence. So something happened here. Is it our CME? Is this the CME? No, too short. And most importantly, there is really not a whole lot of change in other parameters. There's no change in temperature. There's very little change in speed. Speed is actually very stable during the passage of this structure. So it
Mhm.
may be one of those small flux ropes that get trapped in solar wind. And actually, again, flux ropes happen on all sort of scale within even slow solar wind and fast solar wind. So it's not unusual to see them. But what happened here? So
Yeah.
first of all, there's a drop in speed. There's a little bit of drop in the temperature. And all of a sudden, magnetic field is getting a little bit more consistent.
Hmm.
And you see that BZ is more stable than you would typically see in fast solar wind. So chances are this is the CME core. So that CME from the fifth got embedded in fast solar wind because speed is still fairly fast. So that could be the speed of CME, could be the speed of the flux rope. But when we start to see speed going up again, that's our exit from the CME and transition into back into fast solar wind. So this is when CME came, at least the core of that CME. Again,
Yeah.
that's just our analysis.
I kind of get it too because the chit chat on the internet was that it happened so close to that corona hole that the likelihood of it being embedded in it was pretty high.
Yeah. Oh yeah.
So here we
And
are.
it wasn't traveling particularly fast,
Yep.
so it may have gotten compressed a little bit, and temperature is higher than we typically see. So again, that's probably a combo event. Trying to tell heads and tails, again, that's just our version, and that's why I have this marked in. This is a possible sheath of the CME. This is possible core. All of it is just fast solar wind.
Yes.
So a little
Correct.
close up of
Yeah.
why we think this is a possibility. So this is clearly a very, very brief flux rope. Then you get this odd transition where you see a little bit of bump in speed. You see very erratic arrival of something. Um, is it fast solar wind? Well, speed is not that fast enough, not fast yet, to really warrant that erratic of the BZ. Usually fluctuates a little slower in a slower solar wind. Um, but it's kind of bumpy all over. So, and that's another bump in speed. Temperature went up. So it's very possible that this is embedded sheath combined with fast solar wind. And there's another structure here, also compressed and sort of you can't tell which way it's going, at least the magnetic field. So it's almost like flat. But this is a very sharp transition. And this is a very sharp transition in speed. So chances are this is our CME core, and then it just exits into fast solar wind again. So I'm fairly confident this is something that has to do with CME. Which part of it, I don't know. But where it starts and where the fast solar wind and like where's the shock, where's the sheaf, where's the fast, just pure fast solar wind? Well, pure fast solar wind is here. Up until here, it's a mess.
Yeah.
But it came with a lot of negative BZ.
Yeah, so Margaret's like, sorry to interrupt, like, yeah, if it was a really, really fast CME, you wouldn't have the increase in speed when the coronal hole came into play. Because well, if it was the really, really fast one, it would overtake it or like
Yeah.
supersede it, basically.
Yeah, it would basically compress it. We have seen
Mm.
super fast CME that arrived with I think speed of over 1,000,
Mm,
but it was traveling within fast solar wind with very low density. So and if it sort of depends on what space traffic is ahead of it. If you have that co-rotating interacting region, if you have a lot of slow solar wind ahead of it, it's going to slow down. It
yeah,
has to slow down because it's experiencing drag force. But if it's traveling through fast solar wind already with low density, it may not lose that much of a speed on the way here. So it depends. This was not super fast CME. I think speed and modeling was about 550 to 600 kilometers per second. So it definitely wasn't traveling that fast. Did it lose speed? Yeah, it did because it had still a lot of slow solar wind ahead of it.
yeah,
So it had to catch up to it. But even fast solar wind was already going faster than the CME.
yeah, and yeah, because it was about the same. Like, I mean, looking at it, it's
Yeah,
about
it
the
was
same.
pretty close.
Yeah, so it wasn't a particularly super strong one,
No,
but you know,
but
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 it had some it was
it had some
it's quite
substorming.
effective. Yeah.
So this is coronal hole, same coronal hole, previous rotation. And this is coronal hole from about the same. So it's a close enough to say that we can compare the structure of it and the shape of it and
Hmm.
see what it did. So you can see the difference. So this is
Yeah.
already fast solar wind. There's probably a flux rope here, flux rope here. You could see that chaotic substorming that we typically get out of fast solar wind. But look what happened here. We had a period when there was a substorm and then it's sustained at the same level. So that's that steady magnetospheric convection when you establish the current and energy is just getting dumped into ionosphere continuously, and we get the recent description I've seen static aurora. It's not really static, it's more diffuse and sort of bubbling and
Yeah, because it's
doing
not
some stuff,
little.
but it's not having a very nice raise and not really doing substorming. So substorm, then this continuous convection, fairly steady because even for that BZ that was fairly erratic, it still was enough to maintain a fairly steady convection. Not very impressive aurora, but then it dropped like a rock. It generated a fairly nice substorm. It was very brief.
Yeah,
And that's pretty typical for substorms that happen in that steady magnetospheric convection. They tend to be fairly brief. They're sort of in and out, 15 minutes, and they're done. So if you're lucky to catch them, catch them. But you really have to watch. And the interval was longer. So typically, what for steady BZ, we get about 3.5 hours or so when it's completely flat. When it's all over the place like that, you get some recovery. So you start to lose the power a little bit, and then you gain it back, and then finally it gets to the substorm. So I think it took about 5 hours for
yeah,
that substorm to happen from the previous substorm. It
it
was a
was
little
pretty long.
unusual. Yeah,
Yeah,
it took a lot longer than I would expect. But again, for this BZ, this is probably what you would expect. So speed, same. Didn't change that much. Few stray particles here. That's probably not even fast solar wind. That could be more of the sort of other source of particles. And
hmm,
then it finally transitioned, did a little bit more of steady convection here before it went to another substorm and another substorm. And then it finally started to subside and substorm strength was getting a little lower. So you could compare and see what happens and what kind of intervals you end up getting. But this is just pure coronal hole with a few short flux ropes. This is a coronal hole with a CME assist and
yes,
you get
yeah,
very different pattern of storming. So that's kind of fun.
it is, and it's fun
And
to like
chances are,
compare.
again, yeah, no, this is those graphs, I love them. It's fun to compare. And you can see when the speed dropped here and what kind of convection you started to get. So this is fun, but chances are we're going to see more of those events when it's a coronal hole blended in with a CME. This is that part of the cycle again.
Yippee.
Yeah, I know. Fun stuff. So again, just a quick one, take home. Um, Coronal hole CME interaction, we definitely can see CME deflections. They're the main problem. Sometimes they are rotated, so trying to predict which part is coming our way gets to be very challenging. Arrival time is affected, and it depends when they fire in relationship to the fast solar wind arrival, and they can happen either earlier or later than predicted. So CMEs always arrive on time, but how we predict them may differ from their actual timing of arrival. We
I
can
like
predict
that.
them and they're going to come later, or they're predicted and they're coming earlier. So they have their own timing. We're only trying to estimate when they're coming. They're going to be very complex. You can tell based on that solar wind pattern. Well, you can't really, but it's going to be very difficult to tell when CME starts, when fast solar wind transitions, and that's going to be particularly challenging when it's more of a glancing blow. So we don't get a CME structure, we don't get a flux rope. In this case, I think there was a flux rope, and that's why speed slowed down and that's why the temperature changed, but sometimes it's going to be impossible to tell. And we may not get a clean flux rope out of it where you can clearly see the rotation. So that challenges the forecast because sometimes we see, oh, Cora arrived. Yay, let's take a look which way it's going to go. Is it going to be sustained BZ south, or it's going to change and become south to north, or it's just going to stick to the north all the time? It's next to impossible when it's blended with fast solar wind.
Yes. So that's frustrating, but
But one good news out of it, it
yeah.
may enhance that fast solar wind in terms of magnetic field strength. So two of those structures together, they tend to be more powerful when coronal hole by itself, again, same coronal hole, or same CME by itself.
Hmm.
If both of them have nice negative BZ, you can get a fairly strong magnetic field. And that combo um, has sort of second best geoeffectiveness out of possible combinations or out of possible big structures. So compound events like CME, CME, if they compress each other and they have negative BZ, they are the strongest. We have seen it with Maystorm.
Yep.
We got to G5. CME combined with coronal hole influence is the second in that geoeffectiveness category. Not as strong as CME-CME interaction and not as powerful in terms of storming, but it can pack a punch. It can get to G3
Hmm.
with a little of assist. This one got to G2, and that was also pretty impressive. And again, the difference is with coronal hole, it mm, there are shorter intervals of storming when it's intense. With coronal hole and CME, you get more of a sustained picture where you see that um, there is a substorm, then there is continuous activity that's not very impressive, but give it time and it will eventually substorm again. And that's going to be impressive. Brief, but very impressive.
Agreed.
Now, if
Yeah.
you want to
And
take the
now,
forecast, let's do that.
so yeah, fast solar wind. Like it's coronal hole season, so we have coronal holes in the forecast. But to add to this, this time around we have a lot, like we mentioned earlier, we have a lot more active regions, and those can change the boundaries of the coronal holes. So the forecast, like in Glendale and a couple other, well, the 27-day forecast that people look at, and with coronal holes, take it with a grain of salt right now because of the active regions that we have, because they're going to change the way that these coronal holes look and effectively affect us. Um, so yeah, and then we are heading into, the fall season, so the Russell McFerrin effect starts to come back into play, which would be kind of cool. And what is it? Hold on. Autumn positive. So we want the positive polarity ones now. I love that little that
Snap. Hmm.
yeah, snap, because I'm like, oh yeah. So yeah, that's kind of what we're looking at coming up.
With with one problem,
Uh-huh.
this coronal hole, that's positive polarity that keeps coming back and
Yeah.
probably going to survive another rotation. It's locked in with full moon.
Yeah, yes, yes, very good point. So, like this past week, we had, I was out looking for aurora, and it's like, it's got all this decent activity, and you can't see anything because the moon's out. Of course, in the Arctic regions, that's irrelevant. But us down here in, the lower 48 and the mid latitudes, it's a thing. Th those brief substorms that we're talking about, that can pack a punch, that can out. You can usually see those even with the full moon. They're faint, but you can see them. But again, it's like 15 minutes. So you have to catch it when it happens. Otherwise, it just goes back into the background of light.
Yep, precisely.
So, yeah, darn full moon.
Yeah, and it's annoying because again, those coronal holes, once they sort of pick a longitude, they just keep rotating
Yeah.
with that longitude. And the rotation of the sun and coronal hole is 27 days. So that's roughly the moon cycle,
Yeah. Yes.
where it's
Pretty much
just
it.
solar cycle 25 really picked bad timing.
Yeah. Well, And then like Janelle said too, I mean, we're dealing with all that
Yeah.
wildfire smoke too,
Yeah.
but
Oh, yeah, for sure.
so that's you get all the light of the moon and haze. Yeah, it's just fun. So much fun.
Ooh. Yeah. Some of the webcams that we have been using, they just look like broad daylight. You
Yeah,
can't see anything. You can see
wild.
trees.
Yeah, you can see all the details of land really well. It's like
Yep.
daylight.
Exactly. All right.
Yeah,
So I think that's
yeah,
that's all we got for now. We do have a
okay,
negative polarity hole coming. It will probably generate some storming. Again, it's trans-equatorial, so it crosses the equators, and
yeah.
yep, it will have fast solar wind coming. It will have that compression region with stronger magnetic field ahead of it, so it's going to hit us. And the question is whether or not something else will hit us along with it, and that would be nice to get a little CME assistance.
I know, right?
And yeah. And
Oh yeah,
again, it's frustrating to see all those flares. They're
I
launching
know.
CMEs and it's oh yeah, it's going somewhere.
Yeah, it's going somewhere, but not here.
Yep.
But yeah, I guess yeah, I mean, I didn't add that into the last part, but yeah, well, we got a bunch of active regions coming. So I don't we'll see what
And they
happens.
usually and they usually flare all at the same time. So when we have a
Yeah.
surge coming, we start to see more active regions. We start to see more flaring activity. And some regions are more magnetically connected. So two regions on the west limb were essentially chatting with each other all day today. One would flare, then another would flare. And that kept the activity at a fairly high level. Did we get anything from it? No. Just some
Hmm.
radio noise. That's all.
Yeah, that's it. I'm just responding to the chats.
Yeah.
Like Les is like it's been very useful. And he really likes your graphics
Oh,
and
thank you.
how you explain things because you do a good job explaining things. So
Thank you. Well, Les, we worked on this together actually. So your I was working on analysis as you were working on it, so it really helped bouncing ideas off each other. It really is super helpful, and I'm very happy to have this really international and sort of inter-hemisphere collaboration.
oh yeah, it's a lot of
I'm very
fun.
excited for it.
Yeah, and yeah, because I kind of forget his like because we were talking because we have a background chat where we talk about this, before putting the slides and stuff together. So yeah, we do actually even in the midst of working, like, it's like, oh yeah, this happened. I'm like, oh, that looks pretty cool. Too bad I missed all of it, but it's fine.
Well, yeah, I've seen it in data. So I did a lot of
Yeah.
data chasing last week. I'd rather chase Aurora, but well, oh well.
But sometimes, that's the cards you're dealt, and it's like, well, we'll data chase, it's fine. Let's see what we got here. Are there any theories
Ah,
in the space weather scientific community about the tendency of flares to increase on the limbs?
they
Well, some of
actually
it,
don't
yeah,
increase on
and
the
some of
limbs.
it is if you remember, like we're looking at a flat disk. So what all seems like it's on the limb, there's actually a lot of longitude there that we're not seeing.
Yeah,
So it looks like it's always in these limb things, but those are foreshortened in our view. So it's actually, spread out
yeah,
pretty good.
yeah,
It just looks like the limbs,
yeah.
but
And when
no.
you look at the map, when it's mapped out to the longitudes, where it actually happened, it's a fairly even distribution of flaring, at least on the visible longitude. So we're looking at what are we looking at? Stony Brook
Oh,
longitude. So when we're looking just at the flat disk, not taking into account the rotation, the distribution is fairly even. And that's true for M flares, X flares, and C class flares. So they're like 55 degrees north and south in between those longitudes, and that's where they're happening.
mhm.
When you look at more sort of Carrington, so the rotating longitudes, you start to see a slightly different pictures because they're sort of active or hot longitudes, and they're Carrington, so they rotate. Like the regions tend to cluster at certain longitudes, and that's where they start to come up. And same goes for the coronal holes. They kind of pick the longitude. Their shape changes a little bit, but the center is around the same longitude, give or take, which is why when we get stuck with a full moon and the coronal hole, that's when it's going to keep coming, and we're going to
Yeah.
keep getting frustrated because, again, for this one, we're stuck with a full moon. There's
Mm.
not much moving it. Like a couple days here and there, but it's still full moon. And we're going into the season when it's going to be more geo-effective, so it sucks big time.
Yeah. Guess we just gotta. The one good thing though, the days are getting shorter, so you can kind of work around when the moon before it comes up, after it sets, possibly. When the days get really short.
Yep.
So there's that.
Yeah, there's that.
But
Moonrise,
then, but then the
moonset.
substorm's got to coincide with that particular time frame too. So
Yeah, and they
yeah.
have to be strong enough to be visible at our longitude, which if they come early before the sort of peak of the coronal oval, they have to be stronger to actually show up.
Hmm.
Oh well.
Yeah.
Well, we'll take what we get at mid latitudes.
Yep. That's the name of the game. I'm not going to get it's nature, right? This is
Yep,
nature. We're at the mercy of it, so I'm not gonna. I used to get all upset about it, but I was like, well, this is what it is.
it is
We
what it is.
get good stuff out of it. It just, gets frustrating because everybody gets impatient, but we live in a very impatient world these days, so maybe it's time to practice some patience.
Yeah, and I am very happy when I wake up in the morning when I miss the aurora and other people actually got it.
Yeah.
And it's true for this hemisphere, it's true for Southern Hemisphere. I was very excited when I saw Margaret's post, and she said that people caught aurora in Tasmania and Australia. I'm like, yay! This is exciting. Some
Good, good.
people saw the lights. Yay! We didn't, but somebody did. So yeah, it's all good.
It's all good. Well, on that note, I don't think we have any more questions, but although, wishing about, the wildfire smoke go away, which it will, as we get into the more rainier season with fall. It'll put them back out. But it's the sad reality that we're in right now.
Yeah.
Summer's just wildfire season because things just get hot and dry and you get lightning and it's a bad combination. Oddly though, I have to look this up again, but it looks like some of those Saskatchewan fires were actually started by somebody, which is really annoying. And that stuff just makes me really mad.
Yeah.
Um, but that was something that came across in the news earlier, like when I logged on briefly. So I hate that.
Humans.
Yeah, humans. So anyway, we can let you guys have your evening back if you want. Thanks for being here. Thanks for being patient with, last minute. Like I was talking to Tanya. I was like, I don't know, because like my schedule's all over the place, and I'm like, it's gonna have to be like real last minute if I can do it or not. Like even today, like I didn't know when we were gonna get out, from dropping those cars off. So yeah, but we made it happen.
We did
However,
it.
I think I think what we can plan on from here, I do have Saturday off, so we could do like a more traditional one Saturday, like like a normal time, and then I can start the room 15 minutes early so people get the notification. So we'll make that our goal this week.
That sounds like a plan.
All right. Well, you all have a wonderful evening now, and we will probably see you Saturday.
All right.
Okay. So adios.
Bye.